show that one and only one of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. So today we are going to do this problem. So let us take n be a positive integer. Let n be a positive integer. Positive integer. Positive integer. So, and also let b is equal to 3. So this b belongs to a is equal to bq plus r formula, Euclid division lemma. So b is equal to 3 and q is any integer. Q is any integer. Q be any integer. Then by Euclid's division lemma, division lemma. So we already know Euclid division lemma, a comma b are any positive integers. Then there exists a unique pair of integers q and r such that a is equal to bq plus r, 0 less than r less than b. So we have, basing on that Euclid division lemma, we have n is equal to 3q plus r. So where 0 less than or equal to r less than 3. So now for the first case, let if r is equal to 0, then put the value of r is equal to 0 in the above equation, n is equal to 3q plus r. So we get n is equal to 3q plus 0, so that is equal to 3q. So 3q is a multiple of 3, that is why it is divisible by 3. Divisible by 3. So now let us put adding 2 on both sides in the above equation, n is equal to 3q. So adding 2 on both sides, we get n plus 2 is equal to 3q plus 2. 3q plus 2. So evidently it is not divisible by 3. So it is not divisible by 3. We just add 2 on both sides of n is equal to 3q. We got n plus 2 is equal to 3q plus 2. It is not divisible by 3. Now similarly, if you add 4 on both sides, n plus 4 is equal to 3q plus 4. Adding 4 on both sides to n is equal to 3q, we got n plus 4 is equal to 3q plus 4, which is not divisible by 3. So in the above, only n is equal to 3q is divisible by 3, and remaining n plus 2 and n plus 4 is not divisible by 3. So if r is equal to 1, then n is equal to 3q plus r. 3q plus r, and r means 1. So which is not divisible by 3. 3q plus 1 is not divisible by 3. So now adding 2 on both sides. That means n plus 2 is equal to 3q plus 1. N plus 2 is equal to 3q plus 1 plus 2. That is equal to 3q plus 3. 3q plus 3. So is divisible by 3. Similarly, if you add 4 on both sides to n is equal to 3q plus 1, we will get n plus 4 is equal to 3q plus 5. So which is not divisible by 3. So if r is equal to 1, only n plus 2 is divisible by 3, and remaining n and n plus 4 is not divisible by 3. So if r is equal to 2, then you substitute the value of r is equal to 2 in n is equal to 3q plus r, will get n is equal to 3q plus 2. So which is not divisible by 3. Is not divisible by 3. Not divisible by 3. So adding 2 on both sides to n is equal to 3q plus 2, we will get n plus 2 is equal to 3q plus 4. 3q plus 4 is not divisible by 3. Similarly, if you add 4 on both sides to n is equal to 3q plus 2, we will get n plus 4 is equal to 3q plus 6. So take 3 as common, we will get q plus 2, 3 times q plus 2. So let q plus 2 be some integer q. So this is 3q, which is divisible by 3. So if r is equal to 2, n plus 2, n plus 4, only n plus 4 is divisible by 3. So what the conclusion is, in the above 3 cases we can observe that only out of n plus 2, n plus 4, only one of them is divisible by 3. So from the above 3 cases, out of n plus 2, n plus 4, n plus 4, n plus 4, 3 divides only one of them. 3 divides only one of them. 3 divides only one of them. Only one of them.